G'day. I used to work on very small work, and before I upgraded the spindle on the Hercus PC200, I tried with a different pulley and belt to get to 3000 RPM, which I did manage to achieve, but there was so little torque there that it didn't matter. It was a waste of time. Now that I've upgraded the spindle driver to a Mineric driver, I thought I'd have a look at it again and see what I could do. Anyway, I was able to achieve 4000 RPM. That's a bung that I made up to stop the bar rattling in the spindle. I thought at 4000 RPM I didn't want any run out on the bar. So here we are. We're starting off at 3000 RPM because there's a drill coming up first, and it's just a high-speed steel drill, and it should do about 2000 RPM. I normally run it at 3000, so I really didn't want to try running it at 4000. Maybe I'm just not brave enough, I don't know. Yeah, so here's it's just a standard stub drill, and then we have a delay while we speed up to 4000 RPM. And of course there was a delay at the beginning where we came back down from 4000 to 3000. That's an aluminium insert. They're really good on brass. When I did my apprenticeship, we were told to use a tool with zero rake on brass. I was told that a long time ago, but those aluminium inserts have a rake of 20 degrees and they work really well. Give you chips that actually turn into spirals rather than the spray that you get if you use a zero rake tool. Now I tap that off, and that's why, because if I don't, if that happens to hit one of the chuck jaws at 3 or 4000 RPM, you get a mess. You're turning out scrap basically. This time we're running all the way through the program at 3000 RPM just to see the difference. There's still the delay while the spindle slows down from 4000 RPM, which is its maximum, to 3000 RPM, but there won't be a delay speeding back up to 4000 RPM for the turning. Still removes material pretty quickly. That's the code for the Sumitomo aluminium insert. The AG signifies that it's got the chip breaker for aluminium. And that's the codes up there for the parting tool and the insert. That insert in the centre actually has 30 degrees of rake, which helps to make it a low cutting force insert. As you can see from the caption, we gained 8 seconds compared with the previous run at 4000 and 3000 RPM. That's the turret set up to do this job. The parting tool is at the top, the turning tool is at the bottom. All the others are just to help balance the turret. It has to be balanced or it will miss tools. Now this is boring a taper and then putting a taper tap into the part. But as you can see from the caption, there's something radically wrong with the lathe. It's banging around something terrible. I don't know whether it's both axes or just the Z axis, but it's lost its ability to accelerate and decelerate properly. It just goes flat out straight away. This travel is at 2000 millimeters per minute, and the lathe will actually do 6000, but I'm not game to run it at that. It's just I think it would just destroy itself. You see a stop tucked up inside the chuck there. That's attached to a Morse taper arbor that's in the spindle. There's the finished parts, and thank you for watching.